All right, so chapter 4. All right, I added one problem. You'll see as we go through this. But again, guys, one of every little bit of thing you're going to see. So that's why I'm just going through some stuff. The beginning is pretty easy. Sketch the angle in standard position. I don't think there's any on there that you have to pick which angle it is, but you guys did that on WebAssign. But if it's positive, your angle goes which way? It starts at the x-axis and goes which way? Up, or, counterclockwise. If it's, if it's negative, it starts at the x-axis and goes down. So here, if we're going to determine which angle the quadrant lies in, and one positive and one negative coterminal. All right, so negative 5 pi over 6. So if I was looking at my unit circle here, and I started on the x-axis, and I went up to positive 5 pi over 6, I would go 1, 2, 3, 4, 5, 6, 7 spaces. You guys see that? So to get to negative 5 pi over 6, I'd start at the x-axis and go down. How many spaces? 1, 2, 3, 4, 5, 6, 7. What do I land on?
7 pi over 6.
What quadrant is that?
That's in the fourth.
It's in the third quadrant. What do you mean what? I'm so lost. Okay. So this angle right here is negative 5 pi over 6. Okay. In order to find where that is on the unit circle, you would start, no, this is positive 5 pi over 6. We want which one? Negative. So you have to start here and count how many spaces you went to get there. It's 1, 2, 3, 4, 5, 6, 7, right? So in order to get the negative one, you would start here at the x-axis and go down 7. So 1, 2, 3, 4, 5, 6, 7. What quadrant is that? That's the third quadrant. Yes, ma'am.
Are we going to the unit circle?
Yes. I will give you a nice big unit circle.
So is the answer just third quadrant?
So it's in the third quadrant, and then they ask you, this is a question that has a bunch of questions in it, but what do they ask you?
Determine the quadrant, list one positive and one negative.
One positive and one negative coterminal. So guys, what are we starting off in? Pi or degrees? Radians or degrees? Radians. If we're starting off in radians, then our answer needs to be in radians. How do you find coterminals? What do we add and subtract? 360 or?
180.
It's minus 360 and plus 360, but we're not in degrees. So what would I use? 2 pi.
Oh, 2 pi.
So if I'm going to add 2 pi here, I say plus 2 pi. Whoops. 2 pi over 1 becomes 12 pi over 6. Agree? So negative 5 pi plus 12 pi gives me 7 pi over 6. That's my positive one.
Oh, wait.
What were to happen if it came out negative, but I'm looking for a positive? What do I do? You just
change it.
No, just change it. We'd add 2 pi again. You just keep adding to get. So then I'm going to find the negative. So it's negative 5 pi over 6 minus 12 pi over 6. And I get what? Negative 17 pi over 6. What are you confused about, Hannah?
Don't you do 1 pi or something like that?
Bless you. Don't you do what? We're not converting to degrees. You're finding coterminals. In order to find one positive, you'd add 2 pi. In order to find a negative, you would subtract 2 pi.
I utterly forgot about that.
So down here, I have the angle 210. Right? We're in, what quadrant is 210 in?
210 is in the third.
Third quadrant. You can see it. How do you find coterminals for degrees?
It's what, 360?
Plus and minus 360. So it's 210 plus 360 and 210 minus 360. Put the angle first. So what's 210 plus 360? 210 plus 360, guys.
570.
How much?
570.
570. All right. And then what's 210 minus 360? Negative what?
150.
Okay, so do I have one positive and one negative coterminal now? Yes? Okay, good. Still don't get the first one with...
Oh, that makes so much sense now. Because you're adding and subtracting 2 pi.
Correct, a whole circle. But we do 2 pi because we start off in radians, so you're just going to do it in radians. So down here, when I come to this question, they say complement and supplement. All right, complement and supplement means 90 and 180. If you're finding a complement and we are in radians, you're going to say pi over 2 minus. If you want to find the supplement, it's pi minus the angle. Always put pi over 2 or pi minus 2. Pi over 2 or pi first. So I'm going to go down here and do 29. I start off with 3 pi over 10, right? And 30 is 2 pi over 21. Yes? Okay. So if I want to find if there is a complement, that means two angles that add up to be pi over 2. So I'm going to say pi over 2 minus 3 pi over 10. Common denominator would be what? 10. So this becomes 5 pi over 10. You guys agree? So 5 pi over 10 minus 3 pi over 10 is 2 pi over 10, which becomes pi over 5. This is the complement. So then I would take just plain old pi over 1, and I subtract 3 pi over 10. Well, what's the common denominator between 1 and 10? 10. So this becomes 10. So what's 10 pi minus 3 pi? 10 minus 3. 7 pi over 10. So this is the supplement. When would my answer be none? If you get a negative, good. So here I'm going to do the same thing. I'm going to say pi over 2 minus 2 pi over 21. And I'm going to say pi over 1 minus 2 pi over 21. Common denominator between 2 and 21. 42. So if I make this 42, what would I have to multiply top and bottom by to make it 42? 21. So this is 21 pi. What would I multiply this by? 2. So 2 times 2 is 4. So I have 21 minus 4 is what? 21 minus 4, guys. Okay, so 17 pi over 42. That's the complement. So if I change this to 21, what's 21 minus 2? 19 pi over 21. That's your supplement.
I'm kind of confused.
With what?
So,
So like here, they're asking for supplement and complement. It's so much easier, guys, when it's in degrees. I know that. That's how we think. That's how we were born to think. Not born to, but you know what I mean. So for the complement, you say 90 minus the angle. So 90 minus 5 is 85 degrees, right? That's our complement. And then for our supplement, what's supplement in degrees? Supplement in degrees.
and 90. Sorry, 180.
180. So 180 minus 5 is 175. That's our supplement. For 108, to find the complement, I say 90 minus 108. What do you know is going to happen here?
It's not going to be.
There's no complement. Why is there no complement?
It's going to end up negative.
Because it's going to be a negative number. Good.
Oh, you don't just do it again?
No.
Oh.
No. So here I'm going to say 180 minus 108, which is
Oh, yep.
how much?
82. 72.
72 degrees, which is our
Oh, yeah.
supplement. Got to remember that, guys. Coterminals are adding and subtracting 2 pi or 360. Complement is 90 degrees or pi over 2, just depending on what you start off in. And supplement is 180 or pi over 2, or pi, depending on what you start off in. Right? So now we come to something like this. This, Hannah, is when we're converting from one to the other. What are we starting off with in 22?
Oh, we're starting with a degree.
Starting with degrees. That means we're trying to go to what? To radians. So what would my conversion factor look like? Pi over 180. Why is 180 degrees going on the bottom? So the degrees cross out. Good. So, guys, what is negative 355 divided by 180? Can I simplify that?
Yes, you can.
At least by 5.
Yeah.
What's 355 divided by 5?
71.
Is it?
71. Well, negative 71.
71. Okay. What's 180 divided by 5?
That is 36.
Okay, does that simplify more?
I don't think so.
So negative 71 pi over 36.
That's it?
That's it. Degrees to radians, radians to degrees. Super easy.
Oh, yeah, I forgot.
So here, I'm starting off in what?
Radians.
Radians, so I want to go to,
Degrees.
that means what needs to cancel out?
180 over pi.
It's 180 over pi. The pi will cancel out.
Oh, right there.
Okay, guys, if you're given Here where it says cosine of theta is 2 over 3. This is not on the unit circle. So they're telling you two things here. They're telling you what? X and R. So when we're trying to find all 6 trig functions, we have X, we have Y, and we have R. So right now, sit down. We have cosine is X, R is our 3, so we have to find Y, correct?
Yeah.
Okay, so how would I do that?
Pythagorean theorem.
Pythagorean theorem. So I have X squared plus Y squared equals 3 squared. 2 squared plus Y squared equals 3 squared. 4 plus Y squared equals 9. Y squared equals 5.
Yep.
So Y equals root 5.
Yep.
Agree?
Agreed.
Okay, so now let's find all 6 trig functions with this new information. I have sine of theta, which is Y over R. So what's my Y? Root 5. And what's my R? 3. So my cosecant, when I flip it, is going to be R over Y, which is
3 over square root of 5.
3 over root 5. Which can we have? Nope, got to rationalize.
But wait, there's more.
There is more. So it's like 3 root 5 over 5. I'm not sure why I wrote upwards like that. But now I have my cosine. We already gave me the cosine, yes?
Yes.
Cosine is X over R.
2 over 3.
So it's 2 over 3. So my secant, my reciprocal function, would be
3 over
R over X, which is 3 over 2. Good.
Regardless of the line.
Tangent, my bad.
I'm not wrong. Alright, come on.
Just go with it. Tangent is Y over X.
Yes.
So it's
Square root of 5 over 2.
square root of 5 over 2.
Yeah.
My cotangent is going to be X over Y.
No, it's going to be 2 over square root of 5.
2 over root 5.
Can't have that.
Got to rationalize. So it's 2 root 5 over 5.
Yup.
Good.
Wait, that's a 2? I'm sorry. Go on.
Which part?
It's after. Don't worry about it. Keep going. We don't have time. Thank you. For the viewers at home.
For the viewers at home, Francisco wanted you to make sure you know it was a 2. Thank you.
Make sure to like, comment.
For the 3 people that are watching this video at home, there you go. Oh, I don't get offended. I'm just kidding. All right, guys, if they give you a triangle and they're telling you, here is theta, here's 2 sides. They're giving you, in regards to theta, what are they giving you?
X and Y?
Okay, but just if we're talking about if theta are opposite, adjacent, that sort of thing, they're giving us opposite and the adjacent. So what do we need to find? The hypotenuse. How do you find the hypotenuse?
The Pythagorean theorem.
All right, so we're going to say 12 squared plus 15 squared equals c squared. Anybody have deja vu?
Yes.
144 plus 225 equals c squared. What's 144 and 225?
369.
369 equals c squared. You guys are waiting on that one. All right, so now how do I find the square root?
You square root it.
Okay, so you guys will have a calculator, right?
Mm-hmm.
If this breaks down, break it down. If it's in decimals as answer choices, use decimals. I'm not going to work this one out because we just keep doing the same problems over and over again. But let's remind ourselves. Sine of theta. So sine is what? Opposite over hypotenuse. So cosecant, oh my goodness, cosecant of theta is hypotenuse over opposite.
Yep.
Cosine of theta,
Is it
adjacent over hypotenuse. So our secant of theta is,
hypotenuse over base?
good. Tangent of theta, toa,
Mm-hmm.
opposite over
Adjacent.
adjacent. Cotangent of theta is adjacent over opposite. Good.
But isn't 12 x and 15 y? And then this
It's not on a coordinate plane. So don't just assume.
Uh-huh.
Because if the triangle were tilted, it would be different.
Wait.
so it's not x, y, and r.
You can look at it that way. Same thing, but just don't assume always, because if it was shifted in any if it was tilted, then you wouldn't have an x and y. Right? Because x and y are like this. No. All right. So, guys, if they give me x and y, I need to find what?
R.
R. So I'm going to say 3 squared plus negative 4 squared equals r squared. 9 plus 16 equals r squared. 25 equals r squared. What's r?
5.
Whoops, yeah. And so now what are we doing? The same thing we've done 15,000 times?
Yes.
All right, if I was to find the sine of theta,
It would be y over r.
y over r, which is negative 4 over 5. So then my cosecant of theta is r over y, which would be
5 over 4.
5 over negative 4. Doesn't matter where that negative is. Just make sure it's somewhere, either in front, top, back, whatever. Cosine of theta is x over r, which is
3 over negative. Yeah, 3 over 5.
3 over 5. So then my secant of theta is r over x, which is 5 over 3. Good job. Tangent of theta, y over x. What over what?
Negative 4 over 3.
Negative 4 over 3. So my cotangent of theta is x over y, which is
3 over negative 4.
perfect. Perfect. You guys are good at this. You're good at a lot of stuff. All right, this is what we were just talking about, Emmy. When you are given something, Ms. Stutzman will tell you this. When you're given a cosine or something like that, they're giving you the x, the r, they're giving you the y, but you have to figure out what signs go with what. The way that we do that, first of all, identify. They're giving me x, and they're giving me what?
Y and r.
No, they're not giving me y. They're giving me x, which is
X is 2.
negative 2.
Yes.
How do I know the x is negative 2?
Because r is going through the Pythagorean
R is always going to be positive.
Yeah.
But now I need to figure out what the sign, S-I-G-N, is of y. So I'm going to draw my little thing. So all students take calculus, yes. So if you look at this first example, cosine is negative. So what can I cross off that I right away I can cross off? Which two quadrants? A, the first one, because all things are positive there. And what else?
The cos.
The fourth quadrant, because that's where cosine is positive. So now I have the third quadrant and the fourth quadrant.
Uh-huh.
No, second and third, sorry.
Second and
They're
third.
telling me that sine is greater than 0. That means sine is
Positive.
positive. So that means I cross off tangent. I know that this angle lies in the second quadrant. That means I know that x is negative and y is positive. So we would go through the motions and we would say 2 squared plus y squared equals 5 squared. 4 plus y squared equals 25. Y squared equals 21. So y equals root 21. Yes?
Nice.
Then we just go through and we find all 6 trig functions. Again. All right, reference angles. Anybody remember anything about reference angles, Francisco?
I happen to do.
How do you remember reference angles, Francisco?
Quarter one. Oh, if the reference angles have to be cute and positive
Just like what?
in a relationship.
Yeah, just like your girlfriend.
Yep.
So they have to be acute and positive. So let's go through the rules real quick. If it's in quadrant 1, the angle that's given is the reference angle because everything in quadrant 1 is acute and positive. If we're in quadrant 2, we take 180 minus theta. That gives us our reference angle. If we're in quadrant 3, we say the theta that they give us minus 180 is our reference angle. And quadrant 4 is what? 360 minus. Good. So remember, you guys will have a unit circle, yes?
Yes.
So in order to find your reference angle, you can use your unit circle. Where is 5 pi over 4?
Somewhere on the reference angle.
What's the degree measure of 5 pi over 4?
It's 20.
225. So if I'm at 225, what quadrant is 225 in?
The third.
The third. So what is my rule for the third quadrant?
Angle minus 180.
Quadrant 3 is going to be 225, because that's my 5 pi over 4, minus 180, which equals 45 degrees, yes?
Yeah.
You got to convert that back to radians, guys, because you started off in radians. So you can either do the conversion, times pi over 180, or just look back on your unit circle and say, where is 45 degrees? Oh, it's pi over 4.
Nice.
So it would be pi over 4.
Fits the bill.
If I am in degrees already, then we're good to go. Where's 264? What quadrant?
Quadrant 3.
It's in quadrant 3. So I would say my rule again is 264 minus 180 gives me 84. 84 degrees.
Yes.
Is 84 acute?
It's-
Yes. Is it positive?
It's positive.
We're good to go.
Girlfriend.
All right. All right. You guys are going to have a question about arc length, that sort of thing. Do you remember this formula? I'm not giving this to you. Remember it. Yes?
Soar?
Yes. The formula SOAR. It's not even how you spell SOAR, but okay.
No, it's just how it's pronounced.
Theta times radius, right? Our theta is always in
Degrees.
radians. Radians, radians, radians. On your test, they're going to give you a problem. And it's going to say, find the measure of the central angle in radians given this. So if I am given 26 and 4, I say 26 equals 4 times theta.
This isn't on my study.
I wrote it down all by myself. So what do I do now to get theta by itself?
Yeah, you divide by 4.
You divide by 4. So I get theta equals 6. Is there a degree measure in your problem?
Absolutely not.
No. So then you assume it's already in radians. You're good to go.
Perfection.
If there is a degree measure that you see, you have to go, I have to convert. But if there's not, you're okay. Same thing here. Look. I have 48 pi equals 10 times theta. Not sure why I wrote pi. So I would do what? Divide both sides by 10. So I have theta equals, can I simplify?
No.
You can simplify.
Wait, oh yeah, well, I guess. But
If I divide top and bottom by 2, I get 24 pi over 5.
if you put 4.8, is that still?
I don't care what you put. You need to pick the right answer.
What am I?
Do you guys see the difference in those two answers?
No.
What's the
You
difference?
have to put it in degrees.
No.
Radians. Oh wait.
They're no different.
They're
One
both
has
in
pi.
radians.
One has pi and one doesn't, but they're both in radians. So don't freak out tomorrow
If you don't see a pi.
if you don't see a pi, or if there's two answers, one has a pi, one doesn't. Don't freak out. Whatever form that your question is in, like this one doesn't have a pi in it, so your answer doesn't have a pi. This one has a pi, so your answer has a pi.
Hard concept.
But then you don't have to convert at all.
Nope. No. Well, no. Okay. Evaluate sine, cosine, and tangent of the angle without using a calculator. Guys, is 7 pi over 3 on the unit circle? Look,
No.
it's not. Anybody remember how to do this one?
Wait, I was showing up. You say it again?
Find sine, cosine, tangent.
Without using a calculator?
Oh wait, but is it like x? Do you convert first?
Okay. Why are we? Let's convert. I want to do what Emmy said. Let's convert.
I'm lost.
Okay. Well, I'm gonna help you find yourself. Pi. Oh, I like it. Now what do I do with 380 and 3 and 180? 3 goes into 3 once. 3 goes into 180.
60 times.
What's 60 times 7?
420.
420. All right, that doesn't help me much because that's bigger than a what?
That's bigger than 360.
So then let's subtract the whole circle. Good. So what do I get now?
80. No, not 80.
It's 60. Wow.
It's 60 degrees. Emmy, look at you, 30, 60, 90. Yay! Okay, guys, where is 60 degrees? In what quadrant?
The first one.
It's in the first quadrant. That means everything is what? Kind of a number. Positive. Okay, we like that.
All
So,
students
wait,
take
I didn't make a good picture.
What?
Okay, it's somewhere here in the first quadrant.
Yeah.
So I'm going to draw my triangle. This is my reference angle. This is my 60 degree.
Mm-hmm.
So what's the pattern? Anybody remember the pattern for a 30, 60, 90?
Square 3.
What's across from the 60?
I remember.
Square 3.
Square root of 3.
Yeah. And then there's a 2 somewhere.
What's on the two is somewhere, but where is it?
It's in the
The 2 is on the hypotenuse, and then a 1 here.
Yo.
Can you guys now find the sine, the cosine, and the tangent
Yes.
of here? Yes, because sine is what value? Sine is the what? X to the y.
Oh, it's the y.
Sine is the y. What is the y value of this triangle?
The 3.
The root 3.
Sorry.
Cosine is what value?
It's the 1.
It's the x,
Yeah,
right?
right.
So cosine is 1.
Yup.
Tangent is
Y over x.
y over x. So what's my y again?
Square root of 3.
Square root of 3 over...
1.
Do I have to do anything?
Absolutely not.
Good. That's where we use our reference angles.
Y over r.
No, that's not tangent.
Same thing. So if you did y over r, that's fine.
Wait, no, it's not.
Yes,
You
it
would do
is.
square root of 3 over 2 for sine. Right? Uh-oh. I broke the math teacher.
No. No. Don't. You're confusing that. No.
Okay, alright.
When you're using the reference angles, and it's a 30, 60, 90, your special right triangles, you have to use the pattern.
The y over
This was a question on your either 4-1 and 4-2 or 4-3, 4-4. I'm not sure. It was one of those. But then, guys, look. What is the last thing that I told you to look at?
Know how to graph all the trig functions.
You are not going to have to graph them by hand.
You're just gonna have to do like.
You might have to recognize the graph. You might have to know amplitude, those sorts of things. Guys, it's not a big part of it, but most of you did pretty well on that test. You have it.
It's okay because.
Francisco, just give me 1 second, sweetheart. You guys have that. You have the videos to look back on. So look at that this afternoon, this evening, whatever. All right, we're good?
Yeah.
We okay?
Mm-hmm.
All right, I appreciate it. Thank you.